I'm Tammy Kolda, an applied mathematician, and this is Unlocking LaTeX Graphics. On this channel, I present tutorials on using TXE and PGFPLOTS. Today I'll talk about plotting the probability distribution function for normal distributions using PGFPLOTS. This includes discussing features of PGFPLOTS such as plotting a math expression with a custom number of samples, defining a default axis style and a default plot style, refining axis limits, customizing the number format of tick marks, and customizing the legend. The videos on this channel are based on my book, Unlocking LaTeX Graphics, as well as some bonus materials. Before we get started, let's set up our document preamble. I use the geometry package to set a custom paper size for my document. This is not something you would normally do, but I do it here to make the output images easier to view on screen. The parseGit package is used to add space between paragraphs, and the hyperref package is used to link the author name back to the YouTube channel. The key package we need today is PGFPLOTS, which is used for creating plots in LaTeX. It's important to do a little bit of setup when you're using PGFPLOTS. In particular, you need to set the compatibility level for PGFPLOTS. Here I set it to version 1.18, which is the latest version as of this recording. I also recommend setting the scale only axis option inside the every axis style, which is applied, as you might guess, to every axis. This ensures that when we set the width and height of an axis, it applies only to the axis itself. If you don't specify this option, PGFPLOTS automatically pads the width and the height by 45 points. Today we're going to plot the standard normal distribution. I provide its probability density function here for reference. Before we create the plot, let's set some default axis styles using the PGFPLOTS set command. The every axis append style key allows us to specify default options that will apply to every axis that we create. Here I set the width and height of the axis, enable major grid lines, set the X and Y axis labels, and set the font size for the tick labels. Further, I set the default plot style to be very thick lines for every plot inside an axis. If I didn't want this style that I specified here to apply to every single axis, I could instead give it a name and then just call that name as an option for my axis environment, and that would populate all the specifications I've done here. If we go down to the plot, I'm plotting a math expression, so I use the keyword expression here. I did another episode on this topic, which I will link in the show notes. I give the formula for the standard normal distribution inside curly braces. When we compile, we're going to see the standard normal distribution plotted at the default 25 samples on the default range -5 to 5. Clearly, this looks terrible with only 25 samples. You can see that there's sort of jagged marks here. It doesn't look like a smooth curve. Let's smooth it out by increasing the number of samples, which we can specify inside the axis options. Let's set the number of samples here to be 100, and we'll recompile, and then we'll see that we get a much smoother curve. I want to make a few other adjustments to the axis now. For the x-axis, by default, PGFPLOTS increases the limits by 10% on each side to provide some padding. However, I want to reduce that because I don't want the explicit -6 and +6 on the axes. I'm going to do this for all axes rather than just one, so I'll add it up here above where I was setting the default every axis style. So I'm going to say enlarge X limits by 0.05, which says 5% rather than the default 10%. So when I compiled this, we see that now the X limits have slightly changed. Additionally, I want to refine the Y-axis tick labels to show exactly one decimal place. You see here that works for everything except for 0, so I want this to show up as 0.0. Again, I'll do this for every axis. So I'm going to do this with the Y tick label style, and then I'm going to do a bunch of PGF number format options. So we have to specify 3 options here: that it's a fixed format, that the precision is 1 decimal place, and that we should fill even when there are zeros. So before compilation, this 0 does not have a decimal, And when I recompile, we get 0.0 there. Now let's plot several normal distributions with different means and variances on the same axis. First, I remind you of the general normal distribution formula, which is given here. F of x is e to the minus x minus mu squared divided by 2 sigma squared, and all of that divided by the square root of 2 pi sigma squared. This is the formula for mean mu and standard deviation sigma, or variance sigma squared. To make it easier to plot multiple normal distributions, I'm going to define a custom function using the declare function key inside the axis options. Here I'm defining a function called normal PDF that takes 3 arguments, x, m, and ss. The argument x is the variable, and that will be what is used as the x-axis in the plot. M is the mean, and ss is sigma squared, or the variance. Then I provide the formula for the normal distribution using these 3 arguments here. Notice that it ends with a semicolon. Finally, I can plot multiple normal distributions by calling this function with different values for the mean and variance, which I do here with a normal PDF with x, 0, and 0.2. I repeat again with x, 0, and 1, again with x, 0, and 5, and lastly with x minus 2 and 0.5. Compiling this, we will see 4 different normal distributions. Again, these curves are just too jagged, so we're going to go ahead and refine this a little bit. We'll change the number of samples to 100 and see what happens. Now it's a little bit smoother. However, it's not quite smooth enough for this narrowest curve. It almost looks like a straight line at the top. So let's increase the number of samples even more to 200 and see if that smooths things out, which it does. Now let's add legend entries to identify each curve using the legend entries key in the axis options. In TXE and PGFPLOTS, anything containing a comma has to be handled carefully, usually meaning we have to use curly braces to group things properly. When I paste this, you see there's 2 levels of commas here, meaning that we need 2 levels of curly braces. Each legend entry is separated by comma. That's the outer level of curly braces, is to keep those commas differentiated from that comma down there. Then each of my legend entries actually has a comma inside of it, so therefore I need another set of curly braces to enclose those. This is very easy to get wrong, so I just want to take some time to point this out. When we compile, we see the legend appear. The legend is overlapping the functions. So let's reduce the font size in the legend style key by adding font equals footnote size. After compilation, we see that it is no longer overlapping the curves. Finally, let's improve the appearance of the legend a bit more. I want to align all the text to the left, which we do with a special key called legend cell align inside of the axis options. If we look at it before and then I compile, after compilation, we see that all the text is now aligned to the left. I hope you enjoyed today's episode on plotting normal distributions. I include a link to the overleaf document that I created today in the show notes. If you found this helpful or interesting, please click like or subscribe. If you have TXE or PGFPLOTS questions, please post them in the comments. If you want to learn more, please check out the other videos. I also have a book, Unlocking LaTeX Graphics, available for purchase at major book retailers. Thanks for watching.